Okay, now getting back into the Angular side of things. You can see here, this is my current our checklist to-do list of things to do, and so done all the tests with different wireless technologies, Sigfox, LoRaWAN, LTE, so I think I got that under control. I've got the interface working to Firebase and data going to the Firestore. So now look at the application and triggers UI. I'll get that done, probably demonstrate that at the end of this video. Then I'll get the triggers actually sending messages to my mobile device in the next video. Look at some of the data analysis that I need to do, and that'll be most of the Angular stuff, and then I can flip back to finishing off anything I need to do on the actual boat monitor board, put in sensors, add different sensors, see that data going through, and we should be close to finish at that point. So probably 2 or 3 more videos to go. Okay, let's continue with the UI. So I'm working on this area down here around applications, and that's going to support the rest of the data I need to display IoT information. So as I go through, I'll show you what the resulting pages look like. So I've created this application. It's really the center of the whole user interface. Is an application contains users, and this is a change from my earlier diagram. Before I had user groups, now I just found I just needed users, so I've associated users, this value here, with an application. The other thing I associated with the application a set of devices. So for example, if it's a boat monitor, it may be all the various boat monitors that I have out there I put under one application. So certain people can see certain applications, and those applications report on various devices. The other piece here are these sub-collections. So an application contains triggers. So triggers are things that do things when a piece of IoT data is seen. So for example, for my mailbox application, when the mailbox is open, it may send a notification to a user. So you can have one or more triggers. The triggers relate to a single sensor, so you'll see sensors here. Same thing with views. So to allow views on data, so you may want to see the trends and say temperature over the last day or the last week. So views is where those different views into IoT data events are defined. How these are put together. So you'll notice on my menu I no longer have a user groups. So let's go into applications. So at the moment I have 2 applications defined for testing, mailbox and boat monitor. So let's have a look at mailbox. So mailbox, like I said, it contains the users who have access to this applications. You click on that to update the list of users. So maybe I'll just change it just to be me being the user of that one. List of devices, so I can select multiple devices that may have something to do with this application. In this case, the only device that has something to do with my mailbox is this device I called my mailbox. So that's okay. There's various triggers that I want to have associated with the mailbox. So if I have a look at the main one, mailbox open, so I want to send a notification when the mailbox gets open. So the trigger action is to send a notification. Other sort of actions might be to send an email instead of a notification to people who are users for that application, or it could be to create a log entry. There could be other actions that happen in the future on a certain IoT event. We define what sensor that applies to. So in this case, I'm interested in the door, mailbox door open close. I define a range of values where that trigger will be fired. So if the value is between 0.1 and 2, and basically when it's a 1, that means that's the value the sensor returns when the mailbox door is opened. So this will fire when that's a 1, but not when it's closed, which is a 0. And I say that the trigger is active, so I can make these inactive or active. So that's an example of a mailbox open trigger. Another example might be this battery one. So again, it's on this battery sensor this time. In this case, it sends an email, and it basically triggered when the voltage drops below 2.7 volts for the internal battery on that device. So the other thing you can have is views. So I've got one view defined for my mailbox application, and in this case I want a view that shows a table of values. So as the mailbox gets opened and closed, I want it to show as a row in a list of values. So I'll see a date and time for every time the mailbox got open. So that's why I chose show a table of values. But the other way of showing it might be as a line chart. Wouldn't make much sense for opening and closing a mailbox, but maybe a scatter chart would. We see over time when the mailbox opened and closed as scatter chart points on a time chart. And then the sensor I select is the mailbox door sensor in this case, not the battery one. So now I've got all these pieces in place. I can go ahead and I'm going to actually go back to my cloud function acquisition logic, because I want to tag these events with the application references as the data comes in. So I'm going to look up applications as well as all the others in that acquisition logic, and then tag the event with the various applications that device belongs to. And the other thing I'm thinking of doing, and I probably will do it in acquisition logic as well, is put in a function to do this triggers. So if it sees a piece of data comes in that's in range for this for a trigger, that the trigger action is performed during the data coming in. That's a bit I wasn't quite sure about, but I was going to put it in a separate function, maybe have it fire off on event create rather than on the data acquisition, but I can't think of a good reason for doing that at the moment, so I'm going to put it all in one, but just modularize it. So if I have to pull it out and put it on a different cloud function trigger, then it's easy to do that. Okay, I'm using the new application and triggers collections in the cloud function. So under my acquisition logic, the change that I made down here is first to get the application information for the device that is sending the data to my Firebase backend. So during the prepare and write event in my acquisition function, I now create an empty array of applications initially. If we did receive a device, and if that device has an ID, then the first thing I do is create an application reference to the applications collection, and then I can use that reference here to get all the applications that have a device reference for the particular device I'm looking at. So I had to create the device reference here as well. So I'm doing an await on application reference with a where clause, where device reference, and which is the array inside the application document that contains the device. So where the array contains that particular device reference, then if I find it, I add that application to my applications array. So the result of this is I get an applications array with all the applications that have a reference to the particular device that's sending the data into my acquisition function. I pass that through to the next function in here, the write event function. So that's getting the applications array going into it. And down here I need to convert each of those applications objects into an application reference, document reference. So that's what this bit of code's doing. So I'm getting an array of application references instead of just applications. And that's when I write the database event or the event document to the Firestore database. You see here I'm sending application references to this application references I created here. So my event now has the list of applications that are in scope for that event. And the other new thing I did is to make use of triggers. So I wanted to update triggers, or have the triggers fire as a new IoT piece of data comes in. So I created this logic event trigger and passing it the event after the ID's been assigned to the event. So let's have a look at this event trigger. So I put that into a new library called trigger. Here's our event trigger function. It takes an event object, so that's the one we just created. It then pulls out all the application references on that event. So those are the application references we just made. We get the actual application document for each of those references. That's what this is doing. And then we call process application sensor trigger and pass on the event and the application information in each case. So this is doing it for each application that is tied to that particular device in that event. So we come in here with the event and the particular application that we want to look at. So what we want to do is find out any triggers that should be fired for that particular event and application. So we want to look up the trigger. So first thing is I put together a collection reference to the triggers for that application, which this one's doing. And then with that trigger collection reference, I'm doing a query on the sensor reference for that trigger to make sure it's the same as the sensor on the event, and also make sure that the trigger is active. So we could have multiple triggers out there for one event for different applications. But if we've found a trigger, then we want to process that trigger. So that's what this is doing here, is first it gets all the actual trigger document here. And then based on that, the trigger action, it does one of three things. So it always writes a trigger log entry, no matter what. So it's going to write to the Firestore database. There's a collection called triggerlogs, so it's going to write an entry there whenever a trigger should be fired. And then depending on whether that trigger also has an action of either email or notification, then it's going to perform the logic to do that. I'm going to dig into these in the next video because I need to investigate how to do notifications and emails. But you can see here we've got it all set up to call whatever routine does that. And then the final thing here is this write trigger log, and this is the actual function that does that. So we pass it the event, the application, and the trigger for that event, and it does some pre-processing, builds up document references and things, and then writes out the trigger log. The trigger log contains a timestamp, current timestamp, a reference to the trigger, and a reference to the event. So not a lot of data in trigger log document, but it allows us to go backtrack and find out which triggers were fired, and then see what events and what triggers they were fired for. And then it writes out that trigger log entry. And we can test this by, if I go to my acquisition code and up the top here, I have the curl statement that will fire data at my acquisition function. So I can use my Linux subsystem, and I'll use curl to do that. and the result of this should be out in our LoRa Firestore. If I refresh this, so I didn't have any events before. Now I see there's an event, and that's for that curl temperature event that just came in, and I also have a trigger for that particular sensor. So we see here the sensor log shows that that trigger was fired. So it looks like all that code is working. So I'll just have a look at my updated Firestore data layout. I changed this layout a little bit. It hasn't really changed much from the last time we looked at it, except that I show this trigger log collection now, which references the events and the triggers like we just saw. Otherwise everything's the same except for moving things around a little bit. So application still has views and triggers as sub collections. Up here is all the same.